And next up is our third and last fireside chat for today. And for this, I'd like to bring on Alex, who's the co-founder of Matter Labs. A lot of you who know them as ZKsync. So please welcome Alex on stage. Alex, excited to be doing this again with you.
Always a pleasure.
The best part is that every time we do this, there's a new update going on in the ZKsync ecosystem. So we just get to continue our conversation from years, which is awesome. We're going to talk about the Elastic Network today. And my kind of first question to you is, tell us what the Elastic Network is. And let's be a lot of new things coming on.
Sure. So Elastic Network is a ZK rollup cluster, which is the third iteration of the ZKsync protocol. What is a rollup cluster? It's a relatively new emerging concept. It's a collection or a network of chains, rollups, that is designed for enabling seamless interoperability, seamless interactions between the individual accounts on those chains. And this is how it differs from just a random collection of chains. Like, it must be designed from the beginning to remove the boundaries while keeping the identities of the chains intact. Like, they can have their autonomy or sovereignty. They can have different properties. You can think of it as a form of non-fungible sharding. But the connectivity, this unity of these chains is really a key important point.
And in this case, every chain can have a user with different state or different balances, but they still behave like one, or it's just seamless to
No, they behave completely independently. So each of the chains is powered by our framework for building blockchains, the ZK stack. It's the exact same framework which is powering ZKsync Era, the first chain in this network. And all of the chains are completely independent. So you can think of them as just separate layer 2s, layer 1s.
It's awesome. The thing I'm actually kind of curious about is, historically, we've kind of known what ZKsync was trying to do with the ZK VM and kind of being one of the first rollups. But if I'm not mistaken, this is a new sort of direction where you're allowing more chains to be part of the network instead of kind of making ZKsync the chain actually scale up and handle the throughput. What kind of made you to get to this decision, and sort of what's kind of the framing around what made that even more possible?
It's very simple. We're following the market. The market for general purpose chains is quite saturated. Like, optimistic rollups started relatively early. They managed to get a large market share. Then there are alternative layer 1s. I don't see a need of launching one more general purpose chain that does not have something unique, something special that it brings to the table on the business side, or they have to specialize. They have to bring something unique. But we see a huge demand for chains being built for special purposes, like application-specific chains, exchange-specific chains, chains launched by banks and other financial institutions, chains launched by communities. Like, we have gaming chains that are they started off as communities on different blockchains, and then they realized at the end that they want to launch their own chain. It seems a very clear path towards a future where we will have hundreds, if not thousands, of tens of thousands of chains, all working together, just like internet. Like, if you think of the internet, it doesn't run on a single machine, on a single server, or even on a single data center. It runs on many servers. They are all connected. You can browse, you can navigate to every website in exactly the same way. We're using the same browser, the same interface, the same UI, but all of these websites are different, and they perform different functions, and they run on different hardware, but they are unified by this shared interface. And this is something we're replicating. I think this is really the end game for blockchains, for Ethereum as a settlement layer as well.
No, that's actually a really good analogy. So I have two follow-ups from what you just said. One is, in this world, what is the role that ZK Era plays? And then the second piece is, what exactly is allowed to be customized here for others building on ZK Stack? Is it just that if somebody says this chain is going to be for my community, but everything is still possible and those are still general purpose chains, or they can change different properties, and if so, which ones?
Um, you can customize practically everything except for the core engine that connects the chains together. For the system basis of the chains and the virtual machine that must be secured by zero knowledge proofs, because otherwise you defeat the purpose of a ZK rollup cluster. And we can talk about this.
And
So
maybe just so that the audience has a slightly better
sure.
understanding, what falls into like being customizable? So
Yeah. So you can customize. Let's start with data availability. Do you use Ethereum for data availability and you are actually a rollup? Or do you use something external, maybe Celestia or Avail or EigenDA, and then you become a Validium? Or maybe you use your own custom data availability because you're a bank, you want to control it and keep the data private and not disclose to the world. Then you fully control the sequencer. You can decide, do you want a centralized sequencer, which is going to be super highly performant, low latency, thousands of TPS, or you want a decentralized sequencer, and this is going to be a choice for a lot of applications because you can then give the power of sequencing to the community, and you can launch your own token, which will power the staking of this decentralized network and will ensure censorship resistance and decentralization much further. You can customize the rules of the chain, like who you let in, who you let out, like what types of transactions are allowed, what is your base token, could be ETH, but could be also your custom one, and so on.
that's awesome. I mean, that exactly is the flexibility people would like.
Yep, full freedom.
So in that case, what is anywhere from the workflow to the ease of now having chains to talk to each other here, and kind of can you compare that to the other experience that people have where they're going between cross chains, or let's say we use superchain as an analogy? How does this differ between interchain communication?
So interchain communication is something that is going to define rollup clusters, and they're going to make a difference in this is what will make one or another unique. Um, the the kind of the in this endgame that we described, that there are thousands of chains, the interop must be completely seamless in order for this to function as this internet of value. You should be able to connect to any of the chains. Like you as a user, you will probably have your funds on one of the chains on your home location, and you should be able to do what you do now today with your Ethereum wallet, connect to an application, and then just click interact, and you perform the function. And you will be aware what is this application, what chain is it like on, um, what security properties it offers, because they might differ. Right? Validium is very different from a rollup, but the interaction must be completely transparent and seamless and uniform. You just do like one click confirm, something happens, you send tokens over, some interaction occurs, and some results come back. And the difference of ZK rollup cluster compared to something like optimistic rollups is that we use the magic of ZK to guarantee two things: infinite scalability, so there is no fundamental limit on how many chains can join the system and what their throughput can be, which is not the case for optimistic rollup clusters, and isolation. You like whatever like if something happens on one chain, something wrong, you like maybe whoever launched the chain is rugging you, it should not affect anyone else. It should be
Any
contained
other
to
chain
this.
or any user?
It should not like well it cannot it should not affect any other chains. Obviously the users of the chain which is failing will be affected, right? And so
Sorry,
it's
I
your
meant like
risk.
your account on a different chain under the same private key, or you mean just
But
any
exactly, but
theft?
your account on any other chains will be unaffected, and you will and your tokens, your state there will be completely free. And the way this is achieved is very interesting. It's like what ZK as technology is making possible is blockchains that can't be evil. If you think about this, this is basically like this is what we build blockchains for. This is how Bitcoin started. This whole idea of don't trust, verify, don't depend on any central authority. You just uh, are equal peer with everyone else in the network, and collectively you make sure that Bitcoin is uncorruptible. It cannot be evil, right? So this works for Bitcoin because the full nodes are very lightweight. This works for Ethereum also because the nodes are lightweight and the culture of Ethereum keeps it this way. The verifiability must be there. But it becomes very hard when we go in the territory of like chains launching with thousands of TPS, or like when you have like hundreds of thousands of chains, because you cannot anymore run physically verification for all of these chains. So now you have to trust someone or something. And in our case, you will have to trust something. It's math, cryptography, open source code, which you can verify from scratch or rely on other people verifying. You can guarantee, okay, this is, I know the code I'm running. And then all of these chains cannot be evil and will do whatever they are supposed to do according to the, like the properties that they expose.
How does having now external data availability work here? Because you are effectively trusting that data is going to be secure and verified for somebody so that you can have the proofs work on the chain. Is that a good way to understand this?
So the data availability can be completely trustless, and this is the preferable way to do it, which would like the way to do it on Ethereum, if you're settling on Ethereum your chain, is to use Ethereum's data availability, the blobs or even call data, for publishing the state updates of your chain. In which case, you like any user can run Ethereum full node and can guarantee that they get the data, so like it can completely not be rugged. That will not work for everyone. Like, this is not limitless. Ethereum data availability will have some bounds. So in order to exceed that, you will like some chains might want to opt into being validiums, publish data elsewhere. Then only the data censorship resistance properties will be dictated by your data availability solution. So like if you publish on Celestia, then you trust the majority of Celestia validators, for example, right? But then if something goes wrong, if they are becoming malicious, the only thing they can do is to shut down the chain. But they cannot force, like they cannot fake transactions. They cannot interact on your behalf. They cannot steal funds or corrupt the state in any way. So it's like even with validiums, you have halfway there for full trustlessness and cannot be evilness.
No, that's a good way to think about it, because you can't force a state change. You can only just verify that a state was changed. Maybe another simple, quick question. Do you run into any issues with cross-chain transactions or messages when different chains have different base tokens that they're using for fees and not having a balance on one or the other? Like, how does that work in this kind of supercluster world?
That's a challenging problem for many chains. It's easier for ZKsync protocol to handle it because we have native account abstraction from day one. So any chain can interact with, basically you can pay fees in any token. You have to support it. The chain has to kind of enable either the sequencer of the chain directly enables accepting tokens of different kinds, or you run a paymaster and you can convert it just in time within the transaction. And this makes the composability very easy. So you can use basically any, like you can use stablecoin, which will pay, and you use stablecoin, you are making transaction that will go across multiple chains, and you will pay in each of them in the currency, in the base token of that one chain, and you will just convert it just in time.
Super
And
cool.
this is challenging. The interop design is a very complex space. You have to begin with the right user experience. Like imagine like a perfect user experience. What I described in the beginning. You can connect to any chain, one click, everything works. And then you have to work all the way backwards from there. And like, okay, how do we reverse engineer? How do we actually get there?
I guess kind of on that similar note, it's obviously a big discussion topic in our space right now, but let's talk about sequencing and decentralizing that piece. Kind of how are you thinking about it? How do you think about the timelines, and just generally kind of what the plan would be, and any kind of enhancements that you've been working on to make that simpler?
Well, our team recently published a big milestone on decentralization with a consensus mechanism which is permissioned, so without staking yet, but it's working and it's on the testnet. And the next stage will be actually fully running it and implementing it for ERA with staking the token, probably with staking ZK. The chains will be able to also do whatever they want with this. Like this is critical for ERA. And you asked me about ERA, so I didn't answer that question. Era plays a crucial role in the Elastic Network as the first ZK rollup and the place which acts basically like Ethereum of this Elastic Network, this incredibly neutral space where everyone can deploy and have highest censorship resistant guarantees in real time. Our goal is to eventually make it like full real time, like make it even better than Ethereum itself. Maybe use cryptography or TEs or encrypted mempools for like 100% making sure that every transaction can go in. This is important because all the other chains could be run by individual operators or validators, but this must remain the community space where the voting is happening on the governance of the entire Elastic network. We have close to 500,000 individual addresses holding ZKs. It's a very, very broadly decentralized network, and it's also going to be the place where a lot of integrations happen. Already happened. Like we have integrations with all the major bridges, on ramps, oracles, other infrastructure, which then can be all the other chains, especially app chains, can directly tap into this without having to integrate all of it themselves, which is a very, very costly, very expensive, and cumbersome process.
And maybe just to clarify, are you saying that this is the only way for every chain here, or do they have the option to do this on their own?
They can do it on their own, but like, why would you want it?
That cluster?
I mean, like you're building a house. You have a option to tap into the grid and just get electricity from from national grid. You can also build your own generator or your own solar panel if you want to, but like it's a lot easier to just tap into an existing grid. So for some special purposes, if you're building a hospital, you probably want a redundancy power generator. But like most residential houses will just tap into the grid. It's the same situation here. Most like some chains might want to build their own direct integrations for whatever purposes, maybe some special business relations or whatnot. But most app chains don't need to bother about this. It's going to be very, very lightweight for them to start a new chain, just like as easy as starting an application, just deploying on somewhere. But you have all the benefits of the chain, and then you can run like very easily launch a decentralized network. And the incentives for launching that and launching your own token and having like this proper decentralized process and value accrual mechanisms with your community are powerful. And I expect most, if not all, successful apps to eventually become their own app chains. And this is going to be like a really, really big moment. Right now, the home for this app chains is like it's not quite ready. Like ZKsync, the Elastic Network is not quite ready. The optimistic rollup clusters are not quite ready. Like none of them has interop live. ZKsync is furthest along. We have at least the shared bridge live. So when you launch a chain, you can directly tap on, you can build on the shared bridge. Once interop is working, it's going to be available for everyone, not special treatment of the small group of chains that are having some preferences.
No, actually, that's a very helpful way to kind of think about it. So I was mistaken on one of the pieces there. So thanks for clarifying. One kind of thing I'm curious about is obviously we talked about a lot of benefits, but these things are trade-offs at the end of the day. So what are the bottlenecks in this model, or what is actually going to not be as easy compared to the other alternatives? And I'd love to kind of have you tell us about the other side too.
Sure. So right now we expect all the chains in the network to be ZK rollup, or like ZK chains secured by ZK, which comes with trade-offs specific to the
Just
ZK
for
stack.
clarification, does that mean they're running the ZK stack and that's the?
For now, it's only the ZK stack. This can change in the future, but for now it's ZK stack. So like there are limitations of the ZK stack. ZK stack is right now not EVM compatible, not EVM equivalent at bytecode level. This is changing. Like very soon we will ship an upgrade which will enable bytecode compatibility, where like all the UX is completely going to be abstracted away, and then will be as seamless as on layer one and other chains. The proof costs are currently non-negligible. They are like something in the range of like 0.4 cents for an average transaction on Era today. This is going to go down massively with the Bootjump 2.0, which we're going to present, I think, on Friday or Saturday at the ETH Denver. The new benchmarks. It's very, very interesting, very awesome. it's going to bring costs massively down, and we expect the further cost reductions over the coming month and years. At that point, it's going to be, I like. It's hard for me to point to any disadvantages. Like I really believe that ZK is the end game for Ethereum, for all blockchains, and I think we have a broad consensus in the community about this.
That's awesome. So maybe just to complement that, or have you dig in a bit more, as my last question, like what can we expect more this year in addition to EVM equivalence and
EVM equivalence, interop, more updates on the front end side. Stage 1, maybe stage 2. We'll see. I
there's a
became.
lot going on this year.
I'm now more confident that we can come to stage 2 because there are like stage 2 is scary for any rollup cluster, but I think we have found a good trade-off space there. Decentralized sequencer and much higher throughput. We published the roadmap. If you just Google ZKsync roadmap 2025, you will see it all in one picture.
So everything that people have been wanting gets delivered this year.
This year is going to be a big year for ZK.
Pretty awesome. Well, Alex, thank you so much for this amazing conversation.
Thank you, Kartik.
Please give him a big round of applause.